let's jump right into something that's absolutely vital to our modern world. Think about the processed foods industry for a second. The bread, the frozen meals, the snacks sitting in your pantry right now. Producing all of those requires an absolute ocean of water. But how do companies actually measure and report all that water they use, especially when it's becoming such a scarce resource? Well, today, we're zeroing in on exactly how the industry tracks these water metrics, specifically looking at the SASB standard FBPF 140A1.
Because I want you to consider this. What actually happens when a massive food processing factory is located in a region that's basically a desert? Or maybe an area facing a historic, multi-year drought? Look, this isn't just some hypothetical scenario. This is a very real, existential threat to global supply chains. Tracking water risk is absolutely critical for the food industry, simply because you cannot manage what you don't measure. If the tap runs dry, production stops. It literally is that simple.
To make sense of all this, we've put together our drop-by-drop playbook. We're going to break down this standard into 5 logical steps: defining total water withdrawn, calculating total water consumed, mapping baseline water stress, calculating the risk percentage, and finally, mitigating scarcity risks.
Section 1. Defining total water withdrawn.
Okay, before we can calculate any kind of risk, we have to establish exactly what we mean when we say a facility is withdrawing water. Under the SASB standard, total water withdrawn has to be measured in thousands of cubic meters, and it encompasses absolutely everything taken from the local environment or the utility grid. We're talking surface water, so anything drawn from wetlands, rivers, lakes, or oceans. We're talking groundwater pumped straight from aquifers. It even includes rainwater if a facility collects and stores it on site, and of course it covers your standard municipal water supplies. Basically, if you take the water onto your property, it counts as a withdrawal. No exceptions.
Now, companies might also need to break down their supply by source, especially if they're using non-fresh water. But that begs the question, what exactly counts as fresh water? Well, the standard says companies should defer to their local jurisdictional laws first. But if no legal definition exists, SASB provides a specific default threshold. Fresh water is defined as water having less than 1,000 parts per million of dissolved solids. So, unless you're pulling highly saline, salty water, pretty much all standard utility water is going to fit right into this freshwater category.
Moving right along to Section 2, calculating total water consumed.
You see, taking water out of the environment is really only half the equation here. We also have to measure what doesn't go back. Think of it like a bank account. Water withdrawn is like taking money out of an ATM. You physically have the cash. But water consumed, that's spending the cash at a store. It can never go back to your specific local bank branch. In water terms, consumption is the volume that does not return to the exact same local catchment area it was taken from. It is essentially lost to that immediate local environment.
So how does water get consumed, practically speaking? SASB outlines 3 specific criteria for this. First up, evaporation. If water evaporates during withdrawal, during factory use, or even during discharge, it's consumed. Second, it's actually incorporated into the product itself. Think about a can of soup or a frozen pizza. A huge percentage of that weight is literally just water leaving the factory inside the food. And third, if the water gets discharged to a completely different catchment area or just dumped into the sea, it's considered consumed because the original local source never got it back.
Let's head to Section 3, mapping baseline water stress.
So we have our volumes figured out, right? But here's the kicker. 10,000 cubic meters in rainy Scotland means something wildly different than 10,000 cubic meters in drought-stricken California. To make sure every single company uses the exact same geographical yardstick, the SASB standard requires a specific third-party tool. It's called the World Resources Institute's Water Risk Atlas, or Aqueduct. Sustainability officers will literally take the GPS coordinates of all their factories and plug them into this global map to pinpoint the exact scarcity data for those specific locations.
And mapping it out like this gives us clearly defined target risk areas based on the aqueduct classifications. The standard specifically asks companies to pinpoint operations in locations with high or extremely high baseline water stress. What does that mean exactly? Well, high stress means the baseline water stress percentage is sitting between 40 and 80%. Extremely high is anything greater than 80%. Let me be clear. If your factory sits in one of these red zones, every single drop of water you withdraw or consume is highly sensitive.
Which brings us to Section 4, calculating the risk percentage.
This is the real climax of our playbook right here. We're combining our volume metrics with our geographical stress data. It's a straightforward 3-step math problem.
Step 1. Identify the total water withdrawn and consumed across your entire global company. Step 2. Filter out just the volumes used strictly in those high or extremely high stress locations we just talked about. Step 3. Simply divide that stressed volume by your total volume. Because think about it, if 90% of your water comes from an extremely high stress zone, investors immediately know your operations carry massive environmental and financial risk.
And this brilliantly illustrates the exact output required by the standard. When you dig into the water management metrics for code FBPF-140A.1, you see this specific requirement: total water withdrawn, total water consumed, and the percentage of each in regions with high or extremely high baseline water stress. By checking this one simple reporting line, anyone can instantly grasp a company's true exposure to global water shortages.
Wrapping up with Section 5, mitigating scarcity risks.
Now, tracking these numbers isn't just some box-ticking compliance exercise. The ultimate goal here is building resilience before a drought causes your supply chain to completely collapse. The standard outlines some pretty amazing strategies to lower those numbers over time. We're talking efficiency efforts like closed-loop water recycling systems, so you're reusing the exact same water over and over. It can even mean redesigning products from scratch to require less water. It involves upgrading equipment to reduce aquatic impingements or entrainments, which is basically a technical way of saying making sure local fish and marine life don't get trapped in your water intake pipes. And finally, it involves active boots-on-the-ground collaboration with local communities and regulators to manage the shared basin responsibly.
So, I'll leave you with this to chew on. The next time you're wandering down the grocery store aisles looking at the shelves, ask yourself, is your favorite snack resilient enough to survive the next global drought? Because behind the scenes, diligent, standardized water accounting, knowing exactly how much is withdrawn, consumed, and where the stress points are, is exactly what keeps the food industry afloat. Thanks for joining me for this explainer, and remember, keep looking closely at the data.